Alright, so this is our second problem we're looking at. This is a simplified automotive example. Here you can see the model, and also notice the background. This is our multi-CAD version, so it stands apart. You can tell like the buttons are pretty much the same. It does all the same things. It just has a little bit different interface. Okay, so this is the problem we're going to look at. Right now, this car, you can see kind of in the picture, the fender up here is higher than the hood over here. So in this case, the hood is under flush, and we're seeing high variation. So DCS is going to come in and try to make suggestions on how to change this. So one suggestion, once it's already been manufactured, we are looking into adding some bumpers that you can see here, and one of the questions is, where can we put these bumpers so that the best flush case will be along this hood to fender interface? So that's what we're going to be looking at in this model. And in order to do this, we decided to test 4 different situations. So we wanted to look at if we place the bumpers right here near the front of the car, and then 3 other cases further back. And we were hoping that by comparing the results of each of these locations, we could find a better placement for the bumpers to reduce that flush measurement. Okay, so now I'm going to go into a little live demo of it to show you what we did in our model. Give us 1 second to update. Okay. So this is the 3DCS version. You can see here it's similar to the other version Sora was showing. We have our compliant modeler's toolbar over here on the left, and the rest of these are all the same buttons. Here's our tree where you can see parts, moves, tolerance, measures, any of our inputs, and this is the graphics window over here where you can see your model. Okay, so there are 3 main inputs to a DCS model: moves, tolerances, and measures. So I'm going to go through how to create those 3 things in this model. Again, this is our problem right here we're looking at. You see the hood is under flush, and so the thing we want to start off with first is creating moves to simulate the manufacturing process. How is the car assembled, and we want to duplicate that. So here you can see we started off by separating our main parts. Again, this is simplified. We just want to show a basic example. So we're going to move the fender and the hood in, and the compliant model that we're using is just for the hood part. We just want to deform that part to see how it affects it. So now I'm going to nominal build, which Sora mentioned earlier, and what this does is it runs all of our moves in order, and now we're looking at, and you can see here, the flushness measure is better because I had turned on one of my bumper moves, and these moves were created previously, so you can toggle them on and off. So that's the flushness measure. Then we're going to split it up, and I'm going to build it step by step so that you can see the individual moves for this car. So the first step is just an initialization move. There you can see the fender. We're moving the hood down to its hinges, and then we're rotating it down to the striker. And now here you can't really see as it's not zoomed in, but we're applying our clamps, which is the compliant part of the model. Okay, so I'm going to open up each of these moves. This is the initialization move, so here we can specify what parts require data, matrices, and this one, let me slow it down for you, there we go. These are our moves. I'm just scrolling through them right now so you can see each of the points, the hinges, the striker. And this is, again, just modeling the manufacturing process. Here are our main clamp points for the hood. We have 2 at the hinges and 1 at the striker, and then the additional 4 moves are our 4 test cases. And as I scroll through, you can see the 4 different clamps I'm using. Each of these are the object and target. We're clamping the hood down to the frame of the car. And again, you can see on the car where those are located. Okay, so those are our moves, and that's what we use to help locate all of the parts. The next part we add, step 2, is tolerances. So right now we've applied tolerances. This is the hood part, and these are all the surface profile or linear tolerances that have been applied to locating features. So here you can see the range. We've input a range of 1.4, for example, and those are the parts that it's applied to. Additionally, we have position tolerances for the hinges, for example, or any circular tolerances. And we can apply size tolerances as well. These are just samples of what we have applied. All right, zooming in again on the flushless measure, you can see. And deviating, as Saurav showed. So this is showing the effect of all of the tolerances. We can see the variation. Let's see if it's coming on your screen.
Yeah, deviation is hard to get across on the board too.
Yes.
The lag.
Sorry if it's lagging a bit on that. But each of those is a different build. So we're seeing, as imperfect parts are put together, we're seeing how our flush measures are changing. So that brings us to our next input and our final input. And this is really an input to create an output. These are called measures, or here I'm showing the bumpers, but these are our measures. And I put these flush measurement points, they're just at arbitrary locations, looking at the flush from the fender to the hood. And there you can see them there. And now I'm going to split it apart so you can see more details. Again, this is to from. We're looking in the direction that's the arrows are pointing to measure what the flushness measure is so we can determine which bumper placement is best. So this is where you specify your spec limits, what's going to be an acceptable case, and you can also click that current button down there, which will tell you the current measurement. You can see it's about 824 right now because it's separated. And now when I press current, it's under flush by 1.9 millimeters. So we've also, we added a bunch of flush measurements. You can add hole pin clearances, gap measures. There's many different kinds you can do. But this is what I'm going to do. I'm going to run 1,000 simulations. So I'm going to try to build 1,000 of these cars and figure out how many are going to be okay with putting the bumpers at the front. So here you see the results window that Saurav showed earlier. Let me maximize it for you. Okay, and you can see it's that's the measure right there on the screen. I'll point it out for you. Oops, I guess it lagged over it, but this is the front measure on the front fender, and you can see that this one's not too out of spec. Our estimated range is around 3, and we're keeping track of all these when we compare the cases. Again, the contributors are at the bottom, which tolerances are having the biggest effect on this specific measurement. And they're all labeled on the screen as well, so you can quickly identify them on the car or whatever model you have. And I can scroll through. These are all, I had 8 flush measurements, so I can scroll through and you can see how the contributors are changing and how the measurement is moving to show you different results. Additionally, I said I put in some gap measurements just so we can check. As we're measuring flush, we don't want to forget about the gap and make sure that the model is okay. Also, just for fun, I'll show you a little bit quick view of our visualization. We're using the gray style because it's easier to see, but we can toggle between different color schemes that have been set up in DCS. Sometimes they'll help with visualizing gap or flush measures based on lighting, and that should help you. Okay, so again, you saw it live, now you're seeing it on PowerPoint. This is our results, and what we're looking at when I did a comparison, for ease, we're just looking at the estimated range you can see up on the left. And this is the range variation on this specific measure. These are the measures, again, that I took measures on. So that's what we're going to be comparing when we're looking at the 4 different bumper placement cases. Okay. So this is a quick chart of our results. Along the x-axis, you can see that each of these is one of our 8 measurements of flush along the hood, and you can kind of see the car in the background. The lines here represent each of our cases of bumper placement. So the red line on top is the case with no bumpers. If we just use the hinges and the striker, what is the flush going to look like? And we're seeing it's giving us the highest variation in flush, which we expect. So then we tried the front bumpers, which are over here, and you can see that's a little bit better. Mid bumpers here, a little bit better again. And then we have a second mid measurement and an upper measurement. And those are, you can see they're crossing. You know, sometimes it's better, sometimes it's worse, depending on the location that we took the measurement. So we have an average variation here, and basically we can look at these results and decide which would be the best option for placing our bumpers. The second thing, we took some gap measurements that I showed you in the model, just to compare it and make sure that we don't want to have great flush, but then the gap is a mess. So this chart, it's meant to show you that they're all the same. What we noticed were it didn't really matter where we placed the bumpers. The gap measurements were all equal. We took 3 gap measurements that I showed you. So in that case, we knew that adjusting bumpers is fine for gap. We just need to focus on the flush. So in conclusion, what I did is I took an average of the flush measurements at each, the flush variation, at each of the different measurements per test case. So over on the left, you can see each of these are the test cases and their location on the hood. And then over here is the average of the flush measurements. So basically, I took it out to the 3rd decimal place so you could see this one is the best, but these two are very close. So maybe if you wanted to continue on this project, you could iterate and put a few more bumper cases over here in this region. But basically, you can look at these results from DCS and be able to determine maybe what would be a good placement for your bumper.